Well, after that rather long first session, which seems to be becoming a bit of a pattern, where I mix the technical with the political, which I do deliberately. Maybe some of you don't like that. Well, fine. There are umpteen other professors you can learn from. It's part of my agenda. I deliberately mix. It's what I want to do. I'm trying to teach the alphas, but I'm trying to influence. Yeah, if you guys are alphas, I'm trying to influence you politically as well. I'm not just a professor of physics and math teaching this stuff. I'm a globist. I hope you will share the dream of living in a global state, which I believe modern and near future technologies will make possible. Especially the phenomenon of BRAD, bit rate annual doubling. In other words, the internet speed doubles every year. That's just going to have huge implications. Well, anyway, I talked about that in the first session. Okay, so moving straight on. Now the let's see. Right, we talked about the position of the head is over the first character, the first symbol of V. Okay, that's here. Now, after the last symbol of V, on the right-hand side, they're just blanks. Right? The blanks just go on infinitely on the tape. So here's an example, a concrete example of a configuration. So these four symbols here. Let's assume the string alphabet or the tape alphabet. They're almost the same. The tape alphabet is a superset of the string alphabet, but it also includes the blank, right? Because what you can have in the tape, well, you can just see. You can have 0, you can have 1, you can have blank. So the tape alphabet is a superset of the string alphabet. And the string alphabet, that's the set of symbols you can have in your inputs, your initial string, which are just zeros and ones. Okay? So it's the binary alphabet. Okay, so let's have a look at this concrete example of a configuration and figure out what's going on. Well, what's the content of the tape? What's on the tape besides all the blanks? You tend to forget about them. Okay. Well, it'll just be U, V concatenated, so it's just that, right? So it's 1011, O, 4 ones, 1011, O, 4 ones. There it is. That's here. That's the contents of your tape. Okay, at that moment, and forget about the blanks. Right. Current state. Well, you just read it off here. Well, it's Q7. The machine is in state Q7. Here. Now this thing here, that's the controller, the control. And this arrow indicates the position of the read-write head of your machine. Now, which is what? Well, where is it? Well, your Q here, remember, it's by convention, it's positioned over the first symbol of your V. Now this here is your U, and this is your V. Well, so it's this, the read-write head, the head is over the 0 here. Okay? The second 0 from the left. First from the left, second from the left. So it's pointing here. Okay? So from this, you're able to write out the contents of the tape. Okay? You know the state of the machine. You put that in here. And the position is, well, the head is over the first symbol of your V. The string is on the right hand side. That's your V here. So it's over the second 0. There it is. Right? Okay, now moving on a bit. Now that we have this very useful, very compact way of writing down the configuration of a Turing machine at any given moment, Remember those three things: the configuration, the current state, current contents on the tape, and the position of the head on the tape. Okay? You can get it just from reading the configuration. Now, so say you're in configuration C1, just some generic configuration, whatever, call it C1. If at the next step your configuration changes to configuration C2, okay, so it goes from C1 to C2. So now, so C1 causes C2, okay, via the transition rule. Okay? So if that happens, you say that C1 yields C2. To yield means to create, to generate, to furnish, to supply, to give, whatever. Okay, so so C1 yields C2. So in other words, from this, in one step, that's important. From this, you get that. Okay, in one step. Yeah, so in one step. So this configuration yields that one, by definition of yields, if you can go from this to that, you can go from this configuration to that configuration in one step. Okay, that's what yields means. All right, now formally we can express that in more detail. Okay, here we're saying the same idea. So we go from this configuration to that configuration in one step. So let's write out like in this style, let's write out this configuration and this one, and then let's analyze how you go from this configuration to that one, more formally. Okay, so we have here three symbols from the tape alphabet. Okay, that's this one, keep on going. And these are strings from that same alphabet, gamma star. And we have two states, Q1 and QJ, QI and QJ. And these, UAQIBV and UQJACV, they're just strings. Oh, sorry, configurations. The configurations. Right? A U here, sort of, a Q, a state, and a V here. And a U, a state, and a V here. So we'll call this configuration C1, and call that configuration C2. And in a minute, you'll see how we transition, in other words, how this yields that. Okay? So how we go from configuration C1 to configuration C2. So this is the more formal description of yielding, how one configuration yields the next. Okay? Alright? So there was the first config that we just mentioned, that was the second one. So how does this yield that one? Well, so yielding happens in one step, right, by definition. So how do we go from this configuration to this configuration in one step? Well, we will use the transition function, right, and the actual now the transition function, if you look on it as a table, transition table, you have all the rules to go from a particular ordered pair into outputs an ordered triple. You have all those rules. Okay, so let's see. So that's C1 and this is C2. So how, in one step, how do we go from C1 to C2? Well, if we have the transition rule in the transition function, if we have this one, QIB, and it yields, it maps to QJ and C and big L. Let's see how we get from this to this, from C1 to C2, given this transition rule, okay, from the transition function. Now, can you see what's happening? Now, look, we're in that state, right? We're in QI, and the read-write head is over now, in a sense, this is your old V, and it's a bit confusing because we've got a different V here. But that's your old V, and this is your old U, in a sense. So you've got U state V. Okay, so you're in state QI, yes, and the position of the read-write head is over the symbol B, yes. Okay, therefore this rule switches on, gets active, if you like, and it executes this. So there's your right-hand side. So it's telling you to switch to state QJ. All right, that becomes QJ. Okay. Overwrite the symbol where you're at the moment by C. So this B will disappear, and you'll get a C there. All right. So having executed two of those three things, because that's what the transition function does. So you've now got UA QJ C V. You follow that logic so far? Right. Now to do the third thing, that's this one, it tells you to move to the left. Now remember what you had? You had UA QJ C V. And now you have to move one to the left. So the symbol on the tape to the left of what's here, now it's now a C, is the A, of course. So you're going to have to move the state to here, between the U and the A. So now you've got U, QJ, A, C, V.